What is blockchain? 1. As mentioned earlier, blockchain is a distributed ledger technology that stores data in a chain of blocks. 1. Each block contains a list of transactions, and once a block is added to the chain, it becomes a permanent part of the blockchain. 2. The data in the blockchain is secured using cryptographic techniques, making it virtually impossible to alter past transactions without the consensus of the network participants. 3. Blockchain's decentralization and transparency ensure that no single entity controls the system, making it resistant to censorship and manipulation. 2. How does blockchain work? 1. The process of adding transactions to the blockchain involves a series of steps. A transaction is initiated by a participant in the network. The transaction is broadcasted to all the nodes in the network. The nodes collect and validate the transactions, ensuring that they adhere to the predefined rules and are not fraudulent. The validated transactions are grouped together into a block. Miners, in POW blockchains, or validators, in POS blockchains, compete to solve a complex mathematical puzzle to add the block to the chain. This process is known as mining or forging, depending on the consensus mechanism used. Once a miner validator successfully solves the puzzle, the new block is added to the blockchain, and the other nodes in the network update their copies of the blockchain. 3. Decentralization and security. 1. Traditional centralized systems rely on a single point of control, making them vulnerable to single points of failure and potential manipulation. 2. In a blockchain network, each participant has access to the entire transaction history, and no central authority governs the system. 3. To alter any past transaction, an attacker would need to control a majority of the network's computing power in POW or hold a significant stake in POS. Such an attack is known as a 51% attack, and it becomes increasingly difficult as the network grows. 4. The use of cryptographic hashing and encryption techniques ensures the integrity and privacy of data in the blockchain. 4. Consensus mechanisms. 1. Consensus mechanisms are essential for reaching agreement on the state of the blockchain and validating transactions without a central authority. 2. Proof of work, POW, is the original consensus mechanism used in Bitcoin. 2. It requires miners to solve complex mathematical puzzles, which is computationally intensive and energy-consuming. 3. Proof of stake, POS, is an alternative consensus mechanism where validators are chosen to create new blocks based on the number of tokens they hold and stake as collateral. 4. Delegated Proof of Stake, DPOS, involves a smaller number of elected validators, delegates, who take turns to produce blocks. 5. Other consensus mechanisms like practical Byzantine fault tolerance, PBFT, proof of authority, POA, and proof of space, POSpace, cater to specific use cases and requirements. 5. Public versus private blockchains. 1. Public blockchains, like Bitcoin and Ethereum, are open to anyone. 1. They operate with a high level of transparency, and anyone can participate in the network, validate transactions, and raid the entire blockchain. 2. Private blockchains, on the other hand, are permissioned and restricted to specific participants who have been granted access. 2. They are often used within organizations or consortia for specific business purposes, where privacy and control are essential. 6. Smart contracts. 1. Smart contracts are self-executing programs with predefined conditions and rules that automatically trigger actions once the conditions are met. 2. Ethereum is the first and most well-known blockchain platform that introduced smart contracts, enabling developers to create decentralized applications, DApps, and deploy them on the blockchain. 3. Smart contracts have various applications, including automated payments, token issuance, decentralized governance, and more. 7. Use cases of blockchain. 1. Cryptocurrencies and digital assets. The most famous use case of blockchain is Bitcoin and other cryptocurrencies, which allow peer-to-peer digital transactions without intermediaries like banks. 2. Supply chain management. Blockchain can improve transparency and traceability in supply chains, reducing fraud and ensuring the authenticity of products. 3. Voting systems. Blockchain can create secure and tamper-resistant voting systems, increasing trust in the democratic process. 4. Identity management and verification. Blockchain can provide a decentralized and secure way to manage identities and personal data. 5. Healthcare records management. Blockchain can enable secure and interoperable sharing of patient data across healthcare providers. 6. Intellectual property protection. Blockchain can help establish ownership and protect intellectual property rights. 7. Decentralized finance, DeFi. Blockchain enables various financial services without intermediaries, such as lending, borrowing, and trading of digital assets. 8. Gaming and virtual assets. Blockchain can support ownership and trade of in-game assets in video games. 8. Challenges. 1. Scalability. Blockchain networks face challenges in handling a large number of transactions per second without compromising decentralization and security. 2. Energy consumption. Proof-of-work blockchains require significant computational power, leading to high energy consumption. 3. Regulatory issues. The regulatory landscape around blockchain and cryptocurrencies is evolving, and legal frameworks vary from country to country. 4. Interoperability. Different blockchains may have different protocols and standards, making it challenging for them to interact seamlessly. 9. Exploring blockchain. 1. To explore blockchain further, consider starting with online resources, tutorials, and courses on blockchain fundamentals, cryptography, and smart contracts. 2. Hands-on experience can be gained through creating simple smart contracts or participating in blockchain development communities. Overall, blockchain technology offers tremendous potential to revolutionize various industries and improve transparency, security, and efficiency in various processes. However, it's essential to keep in mind that it is still an evolving technology with ongoing research and development, and its implementation requires careful consideration of the specific use case and requirements. The future of blockchain holds tremendous promise and potential for transformative changes across various industries. As the technology continues to evolve, it is expected to address current challenges and unlock new opportunities. Here's a thorough elaboration on the future of blockchain. 1. Scalability and performance improvements. 1. One of the most significant challenges facing blockchain is scalability. 1. As blockchain networks grow in size and adoption, they need to handle an increasing number of transactions without compromising speed and efficiency. 2. Solutions such as sharding, off-chain transactions, and Layer 2 protocols like the Lightning Network, for Bitcoin, and state channels, for Ethereum, are being developed to improve blockchain scalability and throughput. 2. Interoperability between blockchains. 1. The future of blockchain will likely involve a focus on interoperability between different blockchain networks. 1. Seamless communication and value transfer between disparate blockchains will enable a more connected and efficient ecosystem. 2. Interoperability protocols, cross-chain bridges, and middleware layers are being researched and developed to facilitate interoperability and data exchange. 3. Enhanced privacy and confidentiality. 1. While blockchain is transparent and secure, certain use cases demand enhanced privacy and confidentiality. 2. Advances in zero-knowledge proofs, ZK snarks, and other cryptographic techniques are expected to enable private transactions without revealing sensitive information to the public. 4. Integration of AI and IoT with blockchain. 1. The combination of blockchain with artificial intelligence, AI, and the Internet of Things, IoT, is set to revolutionize industries such as supply chain management, logistics, and healthcare. 2. IoT devices can record data on the blockchain, ensuring trust and authenticity, while AI algorithms can analyze this data for insights and automated decision-making. 5. Central bank digital currencies, CBDCs. 1. Numerous countries are exploring the development and implementation of central bank digital currencies, CBDCs, using blockchain technology. 1. CBDCs aim to provide a digital equivalent of a nation's fiat currency, offering benefits like faster cross-border payments and increased financial inclusion. 6. Decentralized finance, DeFi, evolution. 1. DeFi has seen tremendous growth in recent years, providing decentralized lending, borrowing, staking, and trading of digital assets. 1. The future of DeFi will likely involve more sophisticated financial products, improved user experience, and regulatory advancements. 7. Governance and DAOs. 1. Decentralized Autonomous Organizations, DAOs, are entities governed by smart contracts and community voting. 1. They allow stakeholders to make decisions transparently and efficiently. 2. The future will see the evolution of DAOs in various sectors, including decentralized governance of projects, businesses, and even cities.